So in the previous video, we looked into the union, intersection and complement of sets. Also, we discussed about how we can identify the region of A union B and A intersection B. So the region that belongs to A union B is the region that is covered by both the circles. So this entire area belongs to the set A union B. And the region of A intersection B would be the common area where the two circles overlap. So that's basically this area. So now that we know to identify the regions of A union B and A intersection B, let's go ahead and identify more regions of different sets. Let's have a look at this question. The universal set is 1, 2, 3 all the way up to 10. A is 1, 5, 7, B is 2, 3, 4, 5, 6. Find the set and shade the region in a Venn diagram. The first thing is that we need to find the set A complement, and then we have to show which region belongs to A complement in a Venn diagram. You know, A complement is everything except A. And if you see what A is 1, 5, 7. So A complement will take everything except 1, 5, 7 from the universal set. So A complement would be 2, 3, 4, 6, 8, 9, 10. Now let's go ahead and try to identify the region that belongs to A complement. Well, we know A complement is basically whatever that is not A. So the region belonging to the set A is everything that belongs inside the circle A. So A complement has to be everything outside the circle A. So the region that belongs to A complement would be everything outside the circle A. So I'm going to shade it like this. So everything that is not A is A complement. Let's go to the second one. So similarly, B complement. I believe now you should be able to understand what B complement is, because we've already discussed about how we can find a complement and how we can shade one. So for B complement, it's going to be everything except B. B has the numbers 2, 3, 4, 5, 6. So everything except those would be 1, and then 2, 3, 4, 5, 6 is taken, 7, 8, 9, 10. And the way you'd shade B complement would be everything outside the circle B. So all of this belongs to B complement. Alright, so for C, we need to find A complement union B. So the set A complement union B is basically the set A complement and the set B put together. So that would be A complement union B would be, so the set A complement we already have here, we've already got that, and the set B is over here. So if we put that together, that's basically 2, 3, 4, 5, 6, 8, 9, 10. So as I've mentioned previously, you don't repeat an element more than once within a set. So if you see A complement also has 2, 3, 4, 6. The set B also has 2, 3, 4, 6. But we only write them once when we write it inside A complement union B. We don't write them twice. Now how would you shade this region? Well, let's think about it. We need to unite. We need to put together A complement and B in the same diagram, right? So let's go ahead and use two different colors. First, I'm going to shade A complement, and we know A complement is everything other than A. So this is A complement, and B is everything inside the B circle. So I'm going to go ahead and shade the circle B in opposite direction. Now whatever that is shaded completely, because remember that union is always combining both the regions. So whatever that is shaded at the end becomes the union set. So now let's reshade this. Well, if we reshade this in considering everything that is shaded right now, the only part that will be left out is this area, except for this part. This part is not shaded. And therefore, what I'm going to do is I'm going to shade the entire Venn diagram except for the red dotted area. So except for that part, I'm going to shade the remaining region. So all of this. And now I can just remove the red parts because we have shaded what we want to shade. Alright, so now let's go for question D. Question D is A complement intersection B. So A complement intersection B. So we know A complement, the same set that we looked at earlier. We know B, that's also the same set that we looked at. And what is intersection? Intersection means finding the common numbers between both the sets. So if we have a look here, the common numbers are 2, 3, 4, 6 because you've got 2 on both the set, 3 on both the set, 4 on both the set, and 6 on both the set. So the common numbers are 2, 3, 4, 6, which will be my intersection set. Alright, now we found the set, but we need to shade the Venn diagram. So how do we shade this? Again, we're going to go about finding the individual regions of each set. So we're going to find A complement first. So let's shade A complement first. Alright, now let's shade B. So I'm going to use a different color. So B is the entire area over here. However, this time we're not going to go ahead and pick everything that is shaded. Why? Because this is not union, this is intersection. Intersection is all about the common area. So we need to find out which is the common area where both the blue color region and the yellow color region overlaps. And if you see this diagram, the overlapping area, the common area between both the sets is this section over here. Because that is the only section where you can see both the yellow strikes and the blue strikes. So that should be the common region. Now that I know the common region, that is the region that belongs to A complement intersection B. So I'm going to go ahead and just shade that region only. So the region that belongs to A complement intersection B would be this region. Alright, let's get to question E. Question E says A union B complement. But what's A union B? We haven't actually found A union B yet, so let's go ahead and find A union B. So I'll write it on top here, A union B. A union B is just putting A and B together. That will be 1, 2, 3, 4, 5, 6, and 7. Okay, so the complement of A union B is everything that does not belong to A union B. And what are those? So if you see here, 1 to 7, all the numbers from 1 to 7 already belong to A union B. So what does not belong to A union B is 8, 9, and 10. 8, 9, 10. Now let's go ahead and shade in the region that belongs to A union B complement. We know that A union B is both the circles A and B put together. So A union B complement has to be everything other than the circles, right? So that should be the outside region. So just the outside region. Alright. And then for the last question, it's A intersection B complement. So let's find what is A intersection B. What's common between A and B? So A intersection B. Well, if you see here, the only thing that is common between A and B is the number 5. So A intersection B would be 5. Now then, what is A intersection B complement? Well, that would be everything other than 5. So 1, 2, 3, 4, 6, 7, 8, 9, 10. Now how do we shade the region? Well, we know that A intersection B is that overlapping part that's right in the middle of the Venn diagram, right? In fact, it is this part over here. So if you want to find everything other than A intersection B, which is A intersection B complement, then that means you will have to shade everything other than the overlapping part, which is everything outside that region. So everything that does not involve with the overlapping part. So hope you understood and enjoyed this video. I understand that shading Venn diagram might be a little harder as it's time consuming and sometimes difficult to visualize, especially when the set becomes more complex. There is another method, however, for shading Venn diagrams which is easier and involves very less visualization, and that will be covered in the next video. So see you then.